Hi everyone, today we are going to understand and code one of the important topics of the big data analytics, that is Bloom filters. Before talking about what it is, let's first discuss what is the problem that led to creation of this algorithm. Moving to the problem statement, for example, you are given a list of spam email IDs that are, you can say, spam, and now you are given the random email IDs and you have to check whether they are spam or not. The possible solutions for this could be, for example, you are given the spam email IDs. You can sort the spam email IDs in the dictionary order, or you can say lexical order. And now, if you're given a random email ID and you have to check whether it is spam or not, what you can do, you can use either the linear search or the binary search. Here, your linear search time complexity would be huge, so you can use the binary search if the sorting of spam email IDs is there. But when the data is huge, when the data is in millions, or you can say the spam email IDs you are given is in millions, then what is the problem that arise? The first one would be obviously the time complexity of sorting would be huge for 1 million data, and also searching would also take time. Apart from that, to store all the email IDs in the array would take a lot of memory, so space complexity would also be huge. So for this, Bloom's filter came into picture. So what it is a space-efficient probabilistic data structure that is used to test whether an element is member of set or not. Now by this, what it means, maybe we can understand what it is in the latest slides. First of all, let's move to the examples where this can be applied. For example, you are given the list of usernames that are already exist, and a user is there and he need to create a new username, so he can check whether the username he is going to create is already exist or not. Another one again, whether the email is spam or not. Third one could also be that you are given a dataset containing all the websites that are genuine. Now you are given a random website domain ID, so you need to check whether it is genuine or fake website. Now how it is work? For example, as I told you, you are given the input values that are, you can say, for example, take the you are given the keywords that belongs to the computer world. So these are the input values. For example, geeks, hello world, C++, Java, virus, monitor. These are the values that belong to the computer world. So what we'll do, we'll take these values and save in a format that is kind of different format that we'll see. So for that, what we'll do, suppose we are given the values, we'll take the count of values, it is like 7 values. So we'll try to make an array that has values that has count more than 7, or maybe you can say double or triple the values that are the count of values that are in the input format, that are in the input array. So we'll take the bit array. Bit array means the array will have the values either 0 or 1. So what we'll do, we'll initialize the bit array with the value as 0, as it is seen below. Now for every input, like first of all the input was geeks. For what we'll do, we'll create k number of hash functions where each hash function would be different or unique. Suppose we are taking key as 3, so we'll take 3 hash functions and we'll pass the value, first input value in the function, and we'll get the output. Now also remember the mode that we're taking, 10 would be the length of the bit array that we're taking. The length of bit array is 10, so we'll take mode as 10, so that you can say the array index out of bound exception would not be occur. So we, for 3 hash values, we will have 3 values, that is 1, 4 and 7. What we'll do, we'll take these 1, 4th and 7th index and mark these as from 0 to 1. If it is 0, mark it as 1. If it is 1 already, then keep it as same. Now for geeks, we'll mark it as 1, 1 and 1. Then what we'll do, For the step 5, we'll repeat the same third and fourth function for next input values. For the same array, then we'll take the value hello. We'll calculate the hash functions for hello value and we'll get 3 values. For 3 values, we will again mark the indexes as 1. Now, so this is how you can say we'll store all the input values in the form of 1 in the bit array. Now, we need to check if given element is present in the array or not. Now, how we can do that? For example, we are given the element world and we need to check if that element world is present in the initial array that we were given or not. Then what we'll do, we'll take this value world and pass it into the k hash functions that we were given already. So there were 3 functions. So we'll take hash 1 of world, hash 2 of world, and hash 3 of world, and check if it is equal to 1. And there could be 2 cases, either it is 1 or 0. If the value is 1, which means that maybe, or we are not sure, but we can say maybe or maybe not, the element could be present in the input list that we were already given previously. But if it is 0, we are sure that the element was not part of the input list. So you can say here the thing that maybe kind of thing, from the maybe kind of thing, we can say that we are not sure. This element, like this algo works on approximation, so we never get the actual result. But uh, again, to reduce the space and time complexity, we have to compromise on this. So again, where it is fails, or you can say where the false positive result we are given. By false positive result, which means that again, here the maybe condition is there. So maybe you can say there may be cases where the value is equal to 1, but still the element world was not present in the list. For example, this is the case. For the given value cat, the hash of cat is 1, 3, and 7. And here for the 1, 3, and 7, the hashes were 1. So we can conclude that the cat was present in the input list that we were given in the starting, but actually it was not true. So you can say false positive rate would also would be there. So we can increase or decrease the value of k in the hash function to reduce the false positive rate. Now let's calculate the probability of false positive rate. For this, we'll assume the size of bit array, that is this one, as x. Now number of input values is the array of input values that were given to us, like C++, hello, example, etc. So we'll take number of input values as y. Now for the hash function h1, what is the probability of choosing any index? For example, for value C++, the h1 of C++ is, for example, 3. Now what is the probability of choosing this index? That would be 1 by x, because there is x number of x length of bit array, so the probability of choosing any index or this index would be 1 by x. Now what would be the probability of not choosing that index, that either this or this index is chosen but not this? That would be 1 minus 1 by x. This value is for one input and one hash function. What would be the value of not choosing any index? Suppose this index for m hash functions, that would be 1 upon 1 minus x raised to power m. For y inputs, suppose we are given two inputs, y inputs, what would be the value of not choosing any index for m hash functions and y inputs? That would be 1 upon 1 minus x m into y. This is the mathematical formula that is already there, which says that epsilon, if 1 minus epsilon raised to the power 1 minus epsilon is equal to 1 upon e. So if we compare this and this formula, we can conclude thus: if we take epsilon as 1 minus x, then what we can do for this thing, 1 upon 1 minus x my, I'm multiplying x by up and down, we can take this as epsilon, and this is as 1 upon epsilon. So this would become 1 raised to the power e, then m y and x, and we can write e raised to the power minus m y and x. That would be probability of not choosing any index if we have y input values and m hash values. Now we need to calculate the false positive rate. What it means that if we are given an input, suppose input is, for example, again cat, what is the probability that it would be chosen, which means that h1 of cat and h2 of cat till h key of cat is 1. For that, if we are choosing any index, suppose this, that would be 1, this also would be 1, and this also would be 1. So for what is the probability of having this index as 1, which would be 1 minus e raised to power minus myx. Why it is? Because we are assuming it is the probability of not choosing that index. So choosing that index would be 1 minus e raised to power minus my by x. It is for one index, but we are taking the k hash values. So, or you can say m hash values. So we'll multiply it by m. So it would be 1 minus e raised to power minus my by x power m. That would be our false positive rate. Now, what would be a true positive rate? By true positive rate, what we means is that the for the input value in the input c++ and hello was there, so we are taking any given value, suppose c++, and what is the probability that c++ is chosen as 1. So from here we can conclude that if given input c++ is there, we are marking all its hashes as 1, 1 and 1, and again if we'll calculate the hash function of c++, it would be always 1, 1, 1. So from this we can conclude that the true positive rate would be 1. Now what would be the false negative rate, which means that now what false negative means, it means that the value is considered as negative but actually it was positive, which means that c++, for c++ we are taking the hash values and at least one of the hash value is 0, but this could not be a case because for c++ we are marking already the hash values as 1, 1 and 1. So again if we'll check, it would always be 1, 1, 1 and none. It cannot be 0. So the false positive negative rate would be 0. Now let's move to the coding part of this problem. Uh, for the coding purpose of Bloom's filter, first of all, what we'll do, we'll import the libraries that are required for this purpose. Then we'll have a CSV file that will contain the emails that are spam and not spam. Out of this, what we'll take, we'll filter the emails that are spam. We'll take the data and store it in the array format. We'll make a bit array as I told you, having all values and 0, and we'll also take a value as constant. Now what we'll do, we'll make two labels, one for spam and 0 for not spam. For all the data that or the input file that we are given, what we'll check if the value is spam or not. If it is spam, we'll append it with the label 1, and if it is not spam, we'll append it with the label 2. And we'll use this function to change this label array into NP array. Then what our next function is to make these values or input values inserted into the bit array. So for that, what first we'll do, we'll write the function, this one, add to Bloom's filter, where what we'll do, we'll enter the label 1, that is spam emails. We'll enter these labels, and what we'll do, first of all, these labels are in the string form, so we need to map these string values into the numeric, or you can say in the matrix format. So we'll use this library, or you can say this function hash string vectorizer, which will map these string values into the numeric format. So this is the code for this purpose. What we'll do, we'll take the data, we'll use this function, or you can say this class, to change or to map string into the numeric format, and we'll return these words in the vector form. Now again, what we need to do, we need to hash and insert these word vectors into the bit array. So this is the code for it. For this, what we're doing, for each word vector, because suppose there is 5 inputs, so for each input, what we're doing, we are using the 3 hash functions. Suppose k value is 3, so 3 hash functions are calculated, 3 hash values are calculated, and for each value that we are given, we'll mark bit array of that index as 1. So this is how values are inserted. Now what is our work? We need to count the values of false positive rate, like how much our model is, or you can say our data structure is going, or how it is working. So for that, what we'll do, we'll take all the input data that was given to us, which contain both the spam and not spam emails. So what we'll do, we'll pass all the values and check if how our algorithm is working. For this, what we'll do, we'll check the false positive rate through this command. Now we'll make a function that is check for calculate hash and check for spam emails. For this, what first of all, what we'll do, we'll take all the label 0 represent all the emails that are not spam. So we'll take all the emails and pass it again into this hashing vectorizer to map it into the numeric format. Again, for each value, what we'll do, we'll calculate the hash values and check if the values is 1. for each hash value if the bit array is 1, 1 and 1. If it is 1, which means that we are given the false positive value, which means that the value, the answer should be negative, but we are given the positive result. So we'll mark as false positive rate, we'll increment it by 1. So this is how we'll get the false positive rate. This is our false positive values. Then we were these are the values that were, you can say, that were detected wrong. This was the total number of values that were not spam, and by taking false positive divided by total number of negative values, we can conclude how much percentage the values that were detected wrong. So we'll run the code. You can see if we can run this code. So from here, what we can conclude, the not spam values were 2,500, and out of these 452 were detected, or you can say were identified wrong, which means that they were not spam but they were considered as spam. So the false positive rate is 0.1808 out of 1. So this is all about Bloom filter. Thank you.